let's take a look at this example. This time we have problem a little bit more complicated. So from what I'm supposed to start to solve this problem? I'm going to again mark these 2 points as a point A, and this is point B. Okay, I have to find the current which goes through resistor R1. Okay, and I'm going to label this current which will go through this branch as a I1. I have to find ID3. ID3 is the current which will go through this diode, and this is going to be my I2. I have to find I total. This is my I total. And I have to find VR3, voltage across this resistor, and power at resistor R4. Okay, so what we're supposed to do first? We have to realize that I total is equal I1 plus I2. Okay, the sum of these two currents will give me I total. This is KCL. You're supposed to realize that I1 is equal to ID2. This is the same current which will go through the diode D2, and this is also the same current which will go through the resistor R1, IR1. So I have I2 is the current which will go through this branch, and this is the same current which will go through the resistor R2. This is IR2. This is also current ID3, and this is also current IR3. Okay, so we have to find the formulas for currents I1, I2, and for I total. So what I have to do? Simply write the formula. I1 is equal, so VAB, the voltage between these 2 points, VAB minus the voltage drop across the silicon diode D2. So I have, let's write VD2 over the resistance which is in this branch over R1. So I have VAB minus VD2, which is equal 0.7 volts, over R1, which is equal 2 kilohms. I can rewrite this as VAB times 1 over 2 kilohms minus 0.7 volts over 2 kilohms. So this is equal VAB times 1 over 2 kilohms is equal 500 microsiemens minus 0.7 volts divided by 2 kilohms. So I have 0.7 divided by 2 exponent 3. This is equal 350 microamps. Okay, so I have, let me write this down over here, minus 350 microamps. Okay, so this is simply my current I1. Next I'm supposed to find I2. I2 is equal the voltage VAB minus the voltage drop across the diode D3 divided by the total resistance of these two resistors. So I have VAB minus VD3 over R2 plus R3. This is equal VAB minus VD3 is the voltage across the germanium diode, so this is 0.3 volts, over R2, which is equal 3 kilohms plus 4 kilohms. This is equal VAB times 1 divided by 7 coulombs, because 3 coulombs plus 4 coulombs is equal to 7 coulombs, minus 0.3 volts over 7 coulombs also. So this is equal, I'll write this down over here, I have 1 divided by 7 coulombs, 1 divided by 7 exponent 3 is equal 142.85 microsiemens. So I have 142, so this is my VAB, VAB times 142.85 microsiemens minus, and I have 0.3 divided by 7 coulombs. So I have 0.3 volts divided by 7 exponent 3. I got 42.85 microamps. So I have 42.85 microamps. So this is my I2. Okay, this is the current which will go through this branch. Next, I'm supposed to write the formula for I total. Okay, so I have I total is equal voltage source minus, let me show it for you, voltage source minus the voltage drop across the diode D1 minus voltage VAB minus the voltage across the diode D4 divided by resistance R4. So this voltage minus this voltage minus this voltage minus this voltage divided by this resistance will give me I total. So I have voltage source minus VD1 minus VAB minus VD4 divided by R4. Okay, so I have voltage source is equal 50 volts minus VD1, I said VD1 is silicon, that's why this is 0.7 volts, minus VAB, we don't know this yet, minus VD4, D4 is silicon, that's why this is 0.7 volts, over R4, which is equal 5 coulombs. Okay, so this is equal, so let me write this down, I total is equal, so we have 50 minus 0.7 volts, and minus 0.7 volts is equal 48.6 volts, so I have 48.6 volts minus VAB over 5 coulombs. Okay, so this is equal, okay, I have 48.6 divided by 5 exponent 3 is equal 9.72 milliamps. So I'm going to split this fraction into two fractions. So I divide this by this, so I get 9.72 milliamps minus, and I'm going to write VAB times 1 divided by 5 coulombs. Okay, so I have 1 divided by 5 exponent 3 equals 200 microsiemens. So this is 200 microsiemens. So other words, keep in mind that anytime there is no coefficient next to the variable, there is always invisible one. So that's why I divide 1 by 5 coulombs. Okay, so if you do not understand what I'm doing over here, you're supposed to repeat the mathematics, okay, about the fractions. Okay, you have to repeat the lessons about fractions. So next, we're supposed to realize that we found the formula for I total. Next, we're supposed to get back to the KCL, which says that I total is equal I1 plus I2. So we found that I total is equal this. So I have 9.72 milliamps, this is my total, minus VAB times 200 microsiemens is equal I1, which is equal, we found VAB times 500 microsiemens minus 350 microamps. So I have VAB times 500 microsiemens minus 350 microamps, and I have plus I2, and we found this is I2, okay? So I have plus, let me write this down over here, plus VAB times 142.85 microsiemens minus 42.85 microamps. Next, I'm supposed to combine the like terms. I want to keep all my VABs on the right side and currents on the left side. Why VABs on the right side? Because both of them on the right side are positive and the one on the left side is negative. So if I'm going to bring the VAB from the left side to the right side, I'm going to have all my VABs positive. Okay, so let me copy them down. So I have 9.72 milliamps, and I'm going to move 350 micro to the other side. So I'm going to have plus 350 microamps, and I have plus 42.85 microamps is equal VAB 500 microsiemens, I'm doing everything step by step, plus VAB, and I have 142.85 microsiemens plus VAB 200 microsiemens. Okay, now we're supposed to combine the like terms. So we have 9.72 exponent 3 negative plus 350 exponent 6 negative plus 42.85 exponent 6 negative. This is equal 10.11 milliamps. So this is equal 10.11 milliamps. This is equal, we have 500 microsiemens plus 142.85 exponent 6 negative plus 200 exponent 6 negative. This is equal 842.85 microsiemens. So I have a VAB times 842.85 microsiemens. Okay, if I want to find VAB, I'm supposed to divide both sides of my equation by 842.85 microsiemens. 842.85 microsiemens. So this and this will cancel out, and I have VAB equals 10.11 exponent 3 negative divided by 842.85 exponent 6 negative divided by 11.99 volts. Okay, so we can say this is approximately 12 volts. So this is my VAB. Next, we're supposed to find the currents IR1, ID3, and I total. We found the formula for I1, which is equal VB minus VD2 over R1. So I'm going to use this formula first. Later on, I'm going to use the formula for I2, VAB minus VD3 over R2 plus R3. And later on, I'm going to use this formula. I total is equal 48.6 volts minus VAB over 5 kilo. Okay, so let me copy down these formulas and perform the calculations. So I have I1 is equal VAB minus VD2 over R1, where VAB we found is equal 12 volts minus VD2, this is silicon diode, so this is 0.7 volts, over R1, which is equal 2 kilo ohms. So this is equal 12 minus 0.7 is equal divided by 2 exponent 3 is equal 5.65 milliamps. Okay, so this is the current I1, and this is my current also IR1. Next, we have formula for I2. I2 we found is equal VAB minus VD3 over R2 plus R3. This is equal VAB we found this is equal 12 volts minus VD3 is the germanium diode, so this is 0.3 volts over R2, which is equal 3 kilo ohms plus R3 4 kilo ohms. This is equal, again we are going to use the calculator, 12 minus 0.3 divided by 7 exponent 3. This is equal 1.67 milliamps. So this is 1.67 milliamps, and this is the same current which will go through the diode D3. Okay, so this is also equal to ID3. Let me show you this one more time, that the current I1 goes through the resistor R1 because these two components are in series circuit. The current is always the same, and I2 goes through the diode D3. Okay, so this is again the series circuit. Okay, these three components are in series, so that's why I say that I2 is equal to ID3. Next, we're supposed to copy formula for I total. Okay, this is the formula for I total. So I have I total is equal 48.6 volts minus VAB over R4. Okay, so this is equal 48.6 volts minus VAB, which is equal 12 volts over R4, which is equal 5 kilo ohms. This is equal 48.6 minus 12 is equal divided by 5 exponent 3. This is equal 7.32 milliamps. Okay, so this is the current which will go through the resistor R4. This is the current which will go through the diode D4, and this is the current which will go through the diode D1. In other words, this is my I total. Okay, so we've found these three currents, and now if you want to verify that our answers are correct, you can always add these two currents and check if this is going to give me, this addition is going to give me this value. So I have 5.65 exponent 3 negative plus 1.67 exponent 3 negative. This is equal 7.32 milliamps. So it means that our calculations are okay so far. Next, we're supposed to find the voltage across resistor R3. So VR3 is going to be equal the current which goes through this resistor times the resistance of this resistor. So let's write the formula first, like always. So I have VR3 is equal IR3 times R3. IR3 we said is equal to I2, okay, and this is equal 1.67 milliamps. So I have 1.67 milliamps times R3, which is equal 4 kilohms. This is equal 1.67 exponent 3 negative times 4 exponent 3. This is equal 6.68 volts. Okay, so this is voltage across resistor R3. Next, we're supposed to find the power. Next, we're supposed to find the power at the resistor R4. So the power at this resistor is equal, PR4 is equal I total, because total current goes through the resistor R4, okay, times R4, square. So I total we found is equal 7.32 milliamps to the second power times R4, which is equal 5 kilohms. This is equal 7.32 exponent 3 negative square times 5 exponent 3. This is equal 267.91 milliwatts. So this is 267.91 milliwatts. Okay, so as you can see, we found all currents, we found the voltage VR3, we found the power, so we can say that the problem is solved.